Right, so first section we're going to look at in Chapter 3 is called Relations and Functions. In this chapter we'll do quite a bit of graphing, okay, drawing lines, some things that are not lines, but mostly things that are lines. All right, so this first example, okay, it's just an example of when you could use coordinates. And I'm going to see if you guys can figure out how. All right, so in this problem, okay, which I think is written on your sheet, it says Anne worked as a lifeguard. And it says in 1 hour she earned $7. Okay? In 2 hours, $14. 3 hours she earned $21, and in 4 hours she earned $28. So can you tell from that how much money she's making an hour? She's making $7 an hour. Okay? And if you think about each sentence I have, there's two things in it. There's time and money, right, in each one. So here's time, 2 hours, 3 hours, 4 hours. And then money, money, and money. Whenever you have two things you want to represent, what's a good way to do it? And we just did that in the warm-up. If you want to represent two numbers together, how can you do that? Well, what are the things called that you graph? They're ordered pairs or coordinates. Okay? So each one of these sentences you can represent as an ordered pair. Okay? So the number of hours she worked and the amount of money she made can all be represented as ordered pairs. Here's exactly the same thing I just read, but a lot shorter.
Yeah, so guys, those ordered pairs, you have S equals, then you have some brackets. Write those coordinates in on that first section where it says S equals and there's a big blank spot with brackets. You want to write in those coordinates. You don't have to write the brackets, but make sure you write the parentheses.
I'm not going to write it for each one, but can somebody just tell me for the first one, what does the 1 mean and what does the 7 mean? 1 is what? Yep, Josh?
Hours.
Yep, that's hours. And what about the 7? Yeah, money. So what we're doing is we're showing a connection between hours, or time, and money. Okay, what's nice about ordered pairs is it's a lot shorter way to write it out. You don't have to write as much words. Right? 2 comma 14 is a lot shorter than writing in 2 hours she made $14. Okay, it's just a lot shorter. Now, when we went through graphing, what did we call the first coordinate? That was always which letter? Yeah, Hannah? X. And the second letter was Y. Okay? That's one name for them. Okay? You can call all the first coordinates x's. So my x's here are 1, 2, 3, 4. And my y's 7, 14, 21, 28. In a couple sentences, I'm going to show you a different name other than using x's and y's. Still means the same thing, but a different name. So now, if we look at this entire set, that thing that I just circled, that's called a relation. Okay? The reason it's a relation is because it's a connection. It's a connection between two numbers. Okay? Sometimes the numbers have a meaning to them, or sometimes they're just numbers like we had in the warm-up that don't really mean anything. Okay? Just numbers we're graphing. Okay, so on that, do you have a spot for that blank?
Most people already have it filled in, Mr. Hager.
Perfect. Okay, so a set of ordered pairs, that's called a relation. All right, so that first coordinate, you guys told me before that was called the x's. Well, another name for the first coordinate, well, here's two names. The domain. Okay? All of the first coordinates are known as the domain. Okay? Or you can also say they're known as the input, and you guys already have input printed on your sheet. Okay, but above input, make sure you fill in the word domain. All right, so now what I want to do is look at our relation, okay, the thing I circled in blue, and knowing that the domain is a list of the first coordinates. Can anybody tell me the domain of what I circled in blue? 1, 2, 3, 4. Perfect. Okay, so on the line that says domain equals, you want to fill in this.
Make sure you put your brackets as best you can. No parentheses, that's okay.
Okay, so the domain is just a list of all the first coordinates. 1, 2, 3, 4. If you ever have a domain where a number repeats, you don't have to write it twice. Okay, so let's say I added, I don't know, I'm just making up another one. Now it doesn't make sense in our word problem, but the domain here is still 1, 2, 3, 4. I already said 1. You don't need to say it twice. Okay, so any question on what the domain or input is? Just another name for X. Well, if we've got another name for X, what else do you think we have another name for?
Y.
Yeah, we have another name for Y. Okay, and the other name for Y is called the range. Okay, or you can also call it output. Okay, so we got a few different words that mean the same thing. The Y's, the range, the output. All the same thing. Okay, so make sure on your notes, above where it says output, you should fill in range. Okay, now I want to do the same thing we just did up above. I want to look back at what I circled. And looking at this relation, can anybody give me all the values in the range? Shannon?
7, 14, 21, and 28.
Yep, these are the values in the range. 7, 14, 21, 28. They are what we call the Y values, okay, or the outputs. Okay, so on the line where it says range, you're going to fill in 7, 14, 21, 28. So in this particular problem, the domain had 4 numbers, the range had 4 numbers, and that was it. Okay? We could have problems where you have many more than that. You could have 50 numbers in the domain. Okay? We're not going to have one with that many, but you could. Okay?
So guys, before Mr. Dave goes on to the next slide, somebody sum up for me what we just talked about. Somebody make it plain and simple for me, what we just talked about domain and range.
Domain is the X and range is the Y.
Perfect, that's all I'm looking for. Domain is the X, range is the Y. That's it. If you're not sure, think of X and Y, right? X comes before Y in the alphabet. Same with domain and range. D comes before R. The domain is the X, the range is the Y. That's basically that whole slide right there, that's what it talks about. The domain is the X, the range is the Y. That's it.
All right, so in this one, we're being given a relation, okay, just a bunch of ordered pairs. They want us to graph it and then identify the domain and range.
So guys, on your thing, you don't have those coordinates. You need to write them in. It says B equals on your sheet, then you have brackets, you have to write in the coordinates.
Okay, so in this problem, we're really doing 2 separate things. You don't have to graph something to find the domain and range. They're just asking us to. All right, so that first point, 3, 0. Easily, how do I graph the point 3, 0? Yeah, right, how many? Perfect. Right, 3. Okay, that's the first point. How about -1, 2? Someone tell me, how do I graph the point -1, 2? Ashley?
Go to the left one, up two.
Left 1, up 2. That's good. How about 4, 1? Can someone else tell me how I graph the point 4, 1? Yep, Nini?
You went to the four, and up one.
Go which way?
Up one,
Up 1. What comes first?
four.
Which way? 4? To the right. So right 4, up 1.
You guys also have to graph these too.
Dominic, how about -2, -1? Left 2 and then what? Careful, that's a negative. Down 1. So left 2, down 1. And how about the last one, Trenton? 1, -2.
1 to the right,
Mhm.
2 down.
1 to the right and 2 down. Okay, so there's our graph. You don't have to connect it. All you're doing is putting those 5 points. Now they want us to identify the domain and the range. Okay, when I write the domain and range, if we can, let's try to put it in order. Okay, rather than just a list of numbers out of order. So look at your x values. What's the lowest x value that I have? And what I'll do is I'll check them off as I go, so that way I can remember. Yep.
-2.
All right. So we got -2. What's the next lowest value in my domain? Let's see, -1. Yep, I agree with that. 1 looks good. We got 3 and 4. Okay, so those are the values in my domain. Questions on that? All right, how about my range? Looks like -2 is the lowest. Okay, how about the next lowest? Yep, I see a -1. All right, what comes next? Okay, we've got 0, and then 1, and then 2. Okay, so those are the 5 values in the range. And that's it. So that's identifying the domain and range. Any questions on the 2 that we just did? Okay. Anybody else need to copy down domain and range? All right. Next one. Do I have to graph it? No. It does not say to graph it. It just says find the domain, find the range.
So guys, for that one, for 1B, same deal. You have to write in the coordinates. There's a thing on your sheet that says M equals, so make sure you write in the coordinates.
So up until now, all the problems we've done, we've had the same amount of numbers in the domain and range. That doesn't always have to happen. Okay, we'll show you an example later today where that doesn't happen. Okay, so copy down the numbers in the relation. Okay, it's 2, 1, 0, 0, -1, -2, 3, 6. Okay. Anybody think they can give me all the numbers in the domain? I guess give people a second to write them. Okay, just a reminder again, what am I looking for with the domain? Those are which ones?
X.
The first ones, the x's. All right, so what are the values in my domain, Marissa? Okay, so -1.
0,
0, okay,
2,
2,
and 3.
and 3. Perfect. Question?
No, it's going to be
You want to do the range? Sure. What's the range?
-2,
All right,
and then 0,
looks good.
1, and 6.
1 and then 6. And that's it. That's your domain and range. Okay, any questions on that one? Now, both of the problems that we just gave you guys, they were special. Look at the first number of each one. 2, 0, -1, 3. Are there any repeats in those 4 numbers I just said?
The numbers that are the same.
No. How about here?
0.
3, -1, 4, -2, 1. Did I just repeat any numbers I said? No. So when you don't have any numbers that repeat, okay, that's something special. Okay, that's called a function. Okay, so when no first coordinates are the same, the relation is called a function. Okay, so now what we're going to get to is instead of just asking you what's the domain, what's the range, we're going to be able to ask you a question like this. What's the domain? What's the range? Do you have a function? Yes or no?
So guys, on your sheet, you have that first thing. When no first coordinates are the same, it is called a function. So in your first little blank there, you want to write in function. Right? The second to last bullet on the page, you want to write in function.
Oh.
Now, you also have on your sheet, it says in a function. You have that second bullet, then you have these first 3 words, in a function. You want to write in everything else. Some of the second coordinates may be the same, but no 2 ordered pairs may have the same first coordinate. So you want to write in,
There's too much. Why are you so set up with it?
so what I just highlighted, you want to write in next to that last bullet on the page. You have the first 3 things. In a function, you're just going to write in the rest.
Okay, so the first thing that it says where it's highlighted, that's important. Some of the second coordinates might be the same. That's okay. We don't care about the second coordinate. All we really care about is the first coordinate. Now, has anybody heard of that word before, function? Some people have heard of it. So, some people, when they think of a function, they think of it more as a picture. Well, the very last thing that we're going to do is we're going to think of functions in terms of pictures rather than as numbers. Okay, but for now, we'll think of them as numbers or coordinates. Mr. Roy, do we have a spot for 2A?
That.
It's supposed to be 3.
I guess not. okay.
All right, so, well, 3B, yeah, that's a different one. Don't write in 3B because we're going to do that one. 2A, B, C, and D, you guys really do have to write these down because we're going to get into what's called a mapping diagram, a table, and ordered pairs. So,
What's that?
you want to just have them write down on a...
No, yeah, it was separate pages, so I must have copied it alongside. Like, as long as we want to go to freebie, I can make
Okay.
copies quick.
Yeah.
Wanna do that?
So guys, what we'll do is we'll jump to 3B, and Mr. Roy is going to make a photocopy of the stuff to do example 2. Thank you, Mr. Roy. All right. Does everybody have this stuff?
Yes.
Okay. So we're going to come back and we're going to do 2A,
Yep.
and then 2B, C, and D.
You don't have that.
You what? You'll have that. All right. So this test, okay, called the vertical line test, which Mr. Roy, when he comes back with the notes from example 2, this is already going to be written on your notes for you. Okay, so you don't need to copy this down. Okay. This is a way that you can determine if something is a function by looking at a picture. Okay, so remember I said we're going to look at functions as numbers. Okay, that's what we're going to do in example 2D, 2C, 2B, and 2A. Okay, in example 3, we're going to look at a function as a picture. Okay? And this is how you can tell by looking at a picture if you have a graph that's a function or not. Okay? We already know how to do it when it's numbers. None of the first coordinates can repeat. But as a picture, you can use this test and it's a lot faster. All you have to do is take and make a vertical line. Just like that. Except actually make it vertical. Let me try again. Okay, take a vertical line. When you draw a vertical line, you can put it anywhere you want on your function. If it hits your function more than once, that's not good. You don't have a function. Okay? If it only hits it once, that's good. That's what you want. That's a function. Okay? So look at this first one. No matter where I put the vertical line, how many times does the vertical line cross that function?
Once.
Just once, no matter where I put it. So this is a function.
Hager.
Yep,
I would have done it.
yep. I just need to sign out.
I don't know if I did it.
Piece of paper is fine, right? Okay, how about this one? If I put a vertical line there, how many times does it hit it? Once, there. How about there?
4 times.
Yeah, now it's hitting a bunch of times. If a vertical line hits more than once, it's not a function. Okay? Anywhere. Even though it only hits once kind of on the end, it hits more than once in the middle. So this is not a function. Okay? I think it's faster to figure out if something is a function when you have a picture rather than when you have numbers. Okay? But we will go back and we're going to do it with numbers in a second. So, any question on how you use the vertical line test to see if something's a function? Draw a vertical line anywhere you want. If it only hits it once, you're good. That's a function. If it hits it more than once, no good. Not a function. Okay? And that's all going to be written on the notes Mr. Roy gives you. Okay. All right, so let's look at this one. Okay, 3A. This one, just watch because this will also be on the notes that Mr. Roy gives you. Okay. It says, is the set here that I have a function? Okay. So I'm going to make a vertical line. And how do I tell if it's a function? I draw a vertical line. And what am I looking for? Right, want to make sure that it only hits my picture once. Okay, now this picture is not connected, it's just dots, but it's the same idea. If I put a vertical line anywhere I want in this picture, will it ever hit something twice? Yeah, where is it going to hit twice?
For those two dots.
Yeah, over here where these two dots are. That's a problem. If a vertical line can hit something twice, what does that mean? Not a function. Okay, so again, you don't have 3a on your notes. It's going to be on the copy Mr. Roy is making right now. So I'll put it back up and let you copy. No, it's not a function. All right, let me make it a little bigger. What are the ordered pairs here? Let's start with this one. 3, 2. Yep. How about this one? Well, I don't want to confuse you by circling. I'll just point to it. That one down in the lower left. Yep.
-1, -3.
-1, -3. Okay. How about that one? What do they call Ashley? -2, 1. -2, 1. And how about this one up here? Yeah. What is it?
You want me to take the coordinates?
Yeah.
Oh, 1, 3.
1, 3.
Oh, -1, 3.
-1.
-3, 3. -2, 3. I don't know what happened there, man. I'm sorry.
All right, I agree. It is one of those. Who can confirm which one? Emma?
-2.
It is -2, 3. Okay, so that's the first step. Okay, just write those down. Now let's do what we did before. What's the domain? It's the x's. How many numbers are in my domain? 4. What's the lowest one? Yep. -2. Okay, how about the next one?
-2 again?
Okay, do we have to write it twice?
No.
Nope. What's the next one?
-1.
-1 and 3. Now, what do you notice about -2? I think Liam already said it.
It's
What did Liam just say about -2?
yeah, they always just say about -2.
Yeah?
There's 2 of them?
It's 2 of them. It repeats. Mr. Roy, can you pass? We need it for this one too.
What happened?
This is example 3A.
Okay.
Thank you. So when we talked about a function, okay, right before we were going to do example 2, look at what we said. In a function, you can't have the first coordinate repeat. That's exactly what this says. In the example we just did, -2 repeated.
Guys, the sheet I'm giving you, 3A is on the bottom.
Okay, so once you get that, just fill in what we've done.
3A is on the bottom of the sheet I'm giving you. It's on the bottom.
How about the range? What's the range here? Yeah, Emily?
It's 1,
All right, I see 1, yep,
2,
2,
3.
and 3. Now, if I asked you, the number 3 repeats, would that be a problem if I asked you if that was a function?
Yes.
Because the number 3 repeats. It's here, and it's there. Does that matter? Look back at what we said right here. Some of the second coordinates could be the same.
Oh, we're
Like the
good.
threes, that's okay. It's the first coordinate. So the fact that the threes repeat, that's okay.
And they also don't repeat because one of them's negative and the other one's positive. Because the -1 and 3 is supposed to be negative because if you...
Oh, thank you. Yes, you're right. That's a negative
That
anyway.
was the other one. It's the other 3. That one.
So the first one, that's right. -1 up 3, that's right. -2 up 1. This one?
It's the second one in from where it says ordered pairs.
This one?
Yes.
-1, 3.
-1 down 3.
Oh, yes, thank you. Perfect. So now that we made that change, what else does that change in my, what does that add to my range? It adds one more number. But carefully, since we just added that negative, it adds one more number to my range. Yep, Eastley, you see what it is? Yeah. 2, -3, 1, +3. I've got the 2, I've got the 3, I've got the 1. I didn't have -3. So this is an example where you have more numbers in the range than the domain. That can happen sometimes. Any questions on that? All right, let's try 3B. Okay. What's, you know what? Just so I have labels for these, you guys don't have to put these labels. Just help me when I'm talking about them. Can somebody give me the coordinates for point A? Marissa? -4, -1. Perfect. How about the coordinates for point B? Yep.
Is it -1, 2?
-1, 2. Good. How about the coordinates for point C? Yep, Ashley? 2, 3. And how about the coordinates for point D? How about Maggie? You see what the coordinates are for point D? Not sure? Well, starting at the origin, which way do you have to go to get to point D? So we go right 1 and then down 1. So that's right 1. It's a +1. And how about down 1? -1, yeah? Okay, so we've got our ordered pairs. Sabrina, can you tell me the domain?
-4, -1, 1, 2.
Yep. And she put it in order, which is perfect. Okay, how about my range? Liam?
-1.
All right, I got -1, and that one happens twice.
Yeah.
Okay,
And then 2.
2
And then 3.
and 3. Okay, now, same question I had last time. Is that a function? Yes. Okay, and there's 2 ways you can tell it's a function. Did any of the x values repeat?
Wait, no.
No. None of the x values repeated. Let me take a vertical line. If I take that line and drag it through, does it ever hit 2 things at the same time? No. It only hits one at a time. So because of that, that's another reason why, yes, it is a function. Okay, so any questions on that one? All right, this one, you don't have to list all the ordered pairs. This one I want to do a little different. Domain is which ones? The x's or the y's? X's. What's the farthest to the left that this graph goes? What x value? The farthest left that it goes is right here. -2. Okay, so the domain in this one is going to be everything from -2. It's going to include this x value, this one, this one, this one, this one, this one, this one, this one. All these x values, all the way to right there. What's the farthest right that this x value goes? We have everything from -2 up to, what number, Vanessa? 5. So this one's a little different. It's not that it just has like a few numbers in it. It has every single number from -2 all the way to +5. It's got 1, 1.6, 1.7, 2.5, 3.9. It has every single number between -2 and 5. How come? What makes this one different than this one?
You don't have points.
Yeah, this isn't points. This one's connected. Okay? Points are just specific values, like 1, 2, 3, 4 points. When you have a line, it's a bunch of numbers between. Okay, that's how you write it, -2 to 5. How about the range? What's the lowest y value in this whole thing? What is it? Yep, okay. 2. That's the lowest y value. And what's the highest y value that I ever hit as I start to go up? 4. And you will hit every number between 2 and 4. You'll hit 3 a bunch of times in here. 3.5 you'll hit right there. Okay? So let's take our vertical line. Let's drag it through. Does it ever hit my graph more than once? Nope. No matter where I put it, never hit it more than once. So what does that mean?
Yes.
Yes. This is a function.
Yeah, sometimes we might just ask you, we might give you like a graph and just say, we won't ask you the domain and range. We'll just say, tell us if it's a function or not. So if it crosses twice, no. If it only goes through once, yes.
Okay, does everybody have example 3? 3A, B, and C.
I need B. Can I see B again?
B? That was B.
That's good.
Right, so now what we'll do is we'll go back and we'll do example 2.
There we go.
Okay, doesn't matter which one we do first.
So we're on that, the second sheet I just gave you, 2A.
Same questions that we just did in example 3, except I'm not giving you a picture. So you can't use the vertical line test. Unless you drew the picture yourself, then you could. Okay. So you have to focus on this. No 2 ordered pairs can have the same first coordinate. So let's look at these. And we'll answer these 3 questions. Domain, range, function. Okay. Let's start with domain. Okay. Anyone think they can tell me the numbers that are in the domain? Jen?
-2, 2,
All right, so we got negative 2,
negative 1,
negative 1,
1, 2, and 3.
1, 2, 3.
Bless you.
Let's see.
Okay, how about my range? Anyone think they can give me the numbers in the range? Or even just, if you're not sure of all of them, maybe just give me like a couple numbers. Yep, Eastley's. All right, I see actually a couple of those. But remember, you don't have to write it twice. Just write each number once. So we got the negative 3. What else? Okay. Negative 1. Okay, what else? 3 and 5. Okay, did I have a repeat here? Okay, I did have a repeat. Which number was a repeat? Negative 3. Is that a repeat in the domain or a repeat in the range? That was a repeat in the range. Are repeats in the range okay?
Yeah.
Yes. Where do we want to avoid repeats? In what?
Domain.
Domain. Okay, so this time, yes, this is a function. Okay, so we just have to avoid repeats in the domain. I don't care about repeats in the range. Even Mr. Roy doesn't care about repeats in the range. He's okay with that.
Big fat yes.
Repeats in the range, okay.
All right. Any questions on that one?
No, sir.
Okay. Let's do the same thing here.
2B?
Yep. Example 2b. What is the domain here? Yep, Antonio?
I can't, oh, okay, sorry.
Do you want me to repeat?
The domain is 6,
That's one of the numbers, yep.
4, and 4.
Yep, 6 and 4. And what did you say? Why did you say 4 twice?
Oh, I know you only write it once, but I said 4 twice because there's 2 4s.
That's right. There are 2 4s. I'm going to come back to that in a second. Okay, so that's important, what Antonio just said. How about the range? Jordy, what's the range there?
Oh, what? I don't know.
What letter are the ranges?
The last number out of the 3.
Each one.
Oh, 3, 2, and 1.
Yep, and I'm just going to write them 1, 2, 3. So now getting back to what Antonio just said. Is this one a function?
No.
Why not?
There's more than one domain.
The domain.
Yeah, we had a repeat right there. Okay, so the answer to this one, no. Okay, so everyone's okay looking at a list and determining if something is a function or not. Okay, so that's one way. You can have a list. This is a table. Still the same idea as a list.
Write in those values, guys, on your chart. You have the chart that's blank, just write in the values. It's 2, 6.
Just don't write it in.
Huh?
Wait, don't write it in.
Make sure you pay attention. Can't see anything. Around the block.
Okay, this time, instead of having everything written as separate, okay, written out, these are your ordered pairs right here. X and a Y, X and a Y, X and Y, X and Y, X and Y. You don't have to tell me what the domain and the range are here. All I want to know is if this is a function.
Which you have to repeat.
Okay, so now if something's a function, you're checking for repeats in the domain. Did we write the word domain up here? No. So you have to know which one of these is the domain. The top one. That's the domain. So that means the bottom one is
Range.
range.
I got it right.
So, is this a function?
No.
No, why not?
There's 2 zeros on the domain.
Right here. There's a repeat in the domain. That's not a function. And that's it. Okay, so any questions about looking at a table and seeing if it's a function? Okay, the last way we can represent it, this is called a mapping diagram. Okay, I think the easiest thing to do with a mapping diagram, if you're confused, is write the coordinates. Okay? So you have an x's on the left, y's on the right. Anyone think they can tell me my first coordinate looking at this chart? My first x goes with which y? Yeah? Yeah, sure. That's one of the coordinates, yeah? So I'm turning this mapping diagram into a list of points. What's the next one? Nini? 3 goes with 15.
11.
And then what's the last one?
11 and 15.
11, 15.
This
Okay.
is a function.
Why is it a function? I have a repeat.
But the repeat's in the range, and that's
Right.
okay.
The repeat's in the range, and that's fine. So that is a function. Hey, when you look at a diagram like this, if you guys don't need to write these coordinates, that's fine. Just some people get a little confused without writing them. Okay, any questions on that one? All right, you guys ready for the last one?
Yes.
All right, so we already did example 3, right?
You did? No.
We should have.
Example A.
We should have done examples 3, A, B, and C. All right, so now go to example 4.
Let's do that stuff for the vertical line test. Do you want them to have that?
It's already on the notes, right?
It's, they have to write it in.
Oh, okay. There's a spot to write it in?
Yeah. Guys, so on that sheet you just had with 2A on the top, it says vertical line test, write that in. Where it says vertical line test, write that. Don't mistake, you already went over it. Just make sure you get it down in your notes.
Where?
Where it says vertical line test on 2A. Maybe we just don't.
Oh, you were last night.
Yeah, write that in. It says vertical line test, you get the 2 bullets right there. Everybody know who we are? Anybody not sure?
Me.
You're not sure where we are?
That's right.
You know what? Not all who wander are lost.
You already know my condition.
See 2 dashes?
Steve.
Anybody else is not sure when they have to write this? I see a lot of people writing, so I hope they're in good shape. Shorty, keep writing, please, thank you.
That's what I'm doing.
That's all. You can't do 2 things at once. I can't do that.
Really?
All right, so far we've gone over 3 different names for the first coordinate. Can somebody tell me one of the names for the first coordinate? Yep,
X.
X, perfect. What's a second name for the first coordinate? Input. Yep, what's a third name?
The
Domain, perfect. Okay, and we also have 3 corresponding names for the second one. We have Y, output, and range. Okay, there's one more name. I know it's like we have so many names, right? There's one more name we can give to the X and to the Y. Okay, and I'm going to show you what that last name is right now. Does everybody have the vertical line test?
Guys, once you're done, if you're done copying the vertical line test, go back to that other sheet that has, I believe it has 3B on the top. So once you're done copying the vertical line test, go back to the sheet with 3B on the top.
Okay, and the last two names we can use are what are called independent and dependent. I think these two names make the most sense when you're doing a word problem. Okay, and I'm going to show you guys an example of how you can read a word problem and figure out which one is which. Because when you read a word problem, they're not going to tell you which one is X and which one is Y.
I always convinced them.
All right, so it can be a little tricky, kind of like the lifeguard problem. How do you know she made money and she worked a certain number of hours? Which one should be X and which one should be Y? Okay, I'm going to show you how you can tell.
Really?
What, Jordy? What's up? All right, so this part, you don't have to write, you're just listening to me. So let's say I have a problem where I make $11 an hour. Okay, there's two things here. There's how many hours I work, and there's how much money I make. One of those is X, one of those is Y. Okay, or one of those is domain, one of them is range. So I ask myself these two questions, and only one of them is going to make sense. Does how much money I make depend on how many hours I work? Or does how much I work depend on how much money I make? Which one of those makes more sense? The first one or the second one?
First one.
First one.
Yeah, the first one. Okay. How much money I make depends on how many hours I work. So money depends on how much I work. Money depends. Money dependent. Okay, that's how you figure it out. Money is dependent. It's dependent on how many hours I work. So how many hours I work is the other one. That's independent. Okay, so we'll try the same thing again in the next problem. See if we can figure out which one is which. Okay, because that's tricky. It is tricky to figure out.
You guys have that word problem written down. You have to copy that down.
Okay, so example 4. They give us a formula, and this formula represents something. It doesn't even really matter what it represents, but it happens to represent how much liquid is left in your glass after you take a certain amount of gulps from it. So, the two things I'm looking at in this problem, I have how much juice is left and how many gulps I take. So, let's ask ourselves the same question I just did before. Does the amount of juice that's left depend on how many gulps I take? Or does how many gulps I take depend on how much juice is left? The first one. Okay. How much, actually let me write it a little shorter. How much juice is left?
And the other thing is, they have to identify the independent.
Right. Thank you. So how much juice is left in ounces depends
You have to write this right now.
on gulps. Juice depends. So juice is which one?
Domain.
Juice depends. Juice is
Range.
Josh? Dependent. Juice is dependent on how many gulps I take.
But also the range is dependent on the domain.
So juice is dependent.
So you guys have this funny thing where it says dependent variable, write in juice. And then the independent will be gulps. So juice is dependent, right? Gulps is independent.
Okay, because I'm in control of how many gulps I take. Okay, I can control that. And depending on how many gulps I take, that's going to affect how much juice is left. Okay, so gulps is independent. I control that. Juice is how much is left. So it gives us 4 values. Okay, and what I want you to do as part of your homework tonight is take these 4 numbers and plug them in for x one at a time and tell me these 4 values right here.
That's homework?
5.
And the worksheet.
So plug these 5 values in and tell me the y values. Okay?
So guys, the homework, all right, goes right along with the notes we did today. It follows the exact same order. So when you're at home, you should have your homework, you should have, while you're doing your homework, if you're not sure about this stuff, you should have your notes right out next to you, so you know what you're doing. We don't just take notes for the heck of it, it's for the fun of it to torture you guys.